So we're going to start with a review of limits. And so the first example that we're going to do is the limit as x goes to 0 of 2x. This is pretty simple. We can just plug in 0 for x, so it becomes 2 times 0, which is 0, and we're done. The second question is if I do the limit as x goes to 0, x divided by 4 is equal to, okay, so we can simply, once again, just plug in 0 for x. It doesn't violate anything, so it's 0. The third question is, okay, the following. So this is where things this is where things get a little tricky, but not that bad. So it's x over 3x. So the problem here is if we substitute x for 0, the denominator becomes 0, which we can't have. So what we need to do now is we need to eliminate the x in the denominator. So what we can do is we can do the limit as x goes to 0. So we'll just rewrite it again. I probably shouldn't have rewritten it, but that's okay. So what I can do is I can cross out the x from the numerator and denominator, and so what I'm left with is simply a third. And I don't, since there's no variable, I don't need to plug in x for 0 anywhere, so I'm just left with a third, and that's my answer. The fourth one is somewhat similar. So we'll have x squared minus 5x over x. So once again, if I sub in 0 for x, the denominator will be 0. So what I need to do is I need to eliminate it. And the way I'm going to eliminate it is by factoring the numerator. So I can factor out an x in the numerator, and what I'm left with is x minus 5. And I have x in the denominator. Now, as you can see, I can cross out the x from the numerator and denominator, and what I'm left with is simply limit as x goes to 0 of x minus 5. So I can sub in 0 now, and what I'm left with is negative 5. I'm just going to move this a little bit. So just give me some room. Okay, perfect. And now I'm just going to go back to this. Okay, so the fifth one that we're going to do is, so this is going to be one where the limit, where x is not going to go to 0. We're going to set it to negative 9. And so this is going to be x squared minus 81 over x plus 9. So if I substitute x for negative 9, if I set the limit to negative 9, the denominator is going to be 0. So once again, I need to eliminate this x plus 9 in the denominator. So how can I do that? If you notice, the numerator is actually a difference of squares, which can be factored. So what that means is I can factor the x squared minus 81 to x plus 9, x minus 9, the whole thing divided by x plus 9. And so you can see that the x plus 9s will cancel out, and what I'm left with is the limit as x goes towards negative 9. I'm left with x minus 9, and so this is negative 9 minus 9, which is negative 18, and I'm done there. Two more examples. The sixth one is just another factoring one. So this is x goes to negative 2, x squared plus 5x plus 6 all over x plus 2. So what we need to do on the top is we need to factor the top, or by the top I mean numerator. And so the limit, so if you factor it, I'm just going to do it for you. So it's x plus 3, x plus 2 divided by x plus 2. Right away I can see that the x plus 2's will cancel out, and I'm left with the limit x goes towards negative 3, negative 2, my mistake, x plus 3 So it's equal to negative 2 plus 3, which is equal to negative 1. Oh, sorry, positive 1. Whew, catching myself at the last minute. All right, now the last example is going to be with square roots. And if you remember, the way to do limits with square roots is you need to take the conjugate. So if you don't remember, I'll just show you. So the limit here is the limit as x goes towards 1, okay? And it's this, I'm going to take the square root of x plus 3 minus 2 over x minus 1. So once again, the denominator will go to 0 if I set the limit as x goes to 1. So I need to eliminate that. So the way to do, and I can see that there's a square root involved. So the way to do these kind of problems is you need to multiply by the conjugate. So the conjugate basically, okay, I'll use it actually different colors. I'll use green. So no, maybe something, I'll just use black. So, okay, so I need to multiply the conjugate. So the conjugate here is x plus 3 plus 2. So it's just like the numerator, except there's a plus. So you just choose a different sign. The operator in between, you simply switch the operator. So x plus 3 plus 2, and I'll just go back to blue. So what we need to do is multiply the numerator by the numerator, denominator by denominator. So the limit once again is x goes to 1. So the first thing I'll do is I'll just write the denominator. So do not expand the denominator. That's just a mistake. So, or it's not a mistake, but it just means it's more work than you need to. Right? Just leave it like that. And in the numerator, if you notice that what it is, it'll end up simply being a difference of squares. So it will be the square root of x plus 3 squared minus 2 squared. So what that equals is the limit as x goes to 1. So the numerator will be x plus 3 because the square root and the square will cancel out, minus 4 over x minus, x minus 1 and x plus 3 square root plus 2. If you notice that x plus 3 minus 4 is actually simply x minus 1. So I can just go ahead and cancel that out right away. This will cancel out with that. So what I'm left in the denominator is the limit, lim, as x goes to 1 over x plus 3 square root plus 2. Now you can plug in the 1. So what you'll get is 1 over the square root of 4 plus 2. So it's 1 over 2 plus 2. So you end up with a quarter. And that's your final answer.